Hello everybody and welcome to exercise 4 on page 73 of the workbook. In this video we will be looking at just part A of this example. Okay, so let's read this together. For each of the following you are given a group G and a normal subgroup H of G. They're telling us that the subgroup is normal. We don't have to check that. And then they'd like us to make a Cayley table for the factor group G mod H. Okay, so let's look at part A here. So they are giving us the group G equals Z12 and a subgroup H that looks like the subgroup generated by 4. So how about if we start out by just thinking about what's in this subgroup? Okay, so Z12 is an additive group, which means that when we think of the subgroup generated by 4, we have to think additively here. So that subgroup is going to contain the identity, which is 0, and it's going to contain 4. And then we want to repeatedly add 4 to itself. So 4 plus 4 would give us 8. And then 8 plus 4 would give us 12. But 12 mod 12 is 0. And that would take us back to the first element. Okay, so the subgroup generated by 4, turns out it just has 3 elements in it. Okay, and the next thing we'd like to know, we're going to try to make a Cayley table for the factor group. It would be nice to know what's in the factor group, G mod H. Okay, and to figure that out, we need to calculate cosets, okay, because that's what a factor group is. It's just a group of cosets. So we'll start with the nicest coset, okay, 0 plus H. Remember, this is an additive group, so we're thinking addition here. And if you take 0 and add it to everything in H, you're just going to get H back again. All right, so we've got 0, 4, 8, so we need an element in our group G that's not 0, 4, or 8. So how about 1? If we take 1 and add it to all of those elements, we're going to get 1, 5, and 9. Okay, there's another coset. Okay, and I look at those first two cosets and notice that 2 hasn't been used. So we'll look at the coset 2 plus H. So let's see, 0 plus 2 is 2, 4 plus 2 is 6. Okay, and 8 plus 2 is 10. All right, and then let's see, 3 hasn't been used, so we'll look at 3 plus H, and that's going to give us 3, 7, and 11. Notice that those 4 cosets partition all of the elements in Z12, all 12 of those elements, so we're done. That's a total list of cosets, and so those 4 sets are exactly the elements that are in this factor group G mod H. Okay, so 0 plus H, which we'll just write as H, 1 plus H, 2 plus H, and 3 plus H. Okay, we are ready to make a Cayley table here. So let's list out our elements. And let's see down the row, 1 plus H, 2 plus H, and 3 plus H. Okay, and just to remind ourselves, our operation is addition here. Okay. Okay, so just to make this a little bit easier to look at, actually, we may need a bit more space here. Let me pick this up and move those elements over a little bit. Okay, so we're going to see if we can calculate those one by one. The first thing to maybe notice is that if you take the coset H, that's really 0 plus H. If you add that to any other coset, you're going to get the same thing back again. It's our identity element. So the first row and the column are going to be fairly easy to figure out. Whoops, that's not H, that's 1 plus H. Okay, and let's see if we can fill in the rest of these. So if we take 1 plus H plus 1 plus H, we're just going to get 2 plus H. Add those two elements together. And then 1 plus H plus 2 plus H is 3 plus H. Okay, and then we come to 1 plus h plus 3 plus h. Okay, these two elements. If you do the addition there, 1 plus 3 is 4. You're actually going to get 4 plus h, but 4 plus h doesn't look exactly like one of these four things that we listed in our group. So which of those four cosets in G mod h is 4 plus h equal to? Well, we can look at our coset representations and notice that the element 4 appears in the coset 0 plus h. That tells us that this is really 4 plus h. So instead of writing 4 plus h, we're going to write h. Okay, that's better notation to be consistent. We want to fill in our Cayley table so that we use exactly these four representations up here. Just makes our Cayley table easier to look at and interpret. Okay, and then continuing, let's see. What about 2 plus h plus 1 plus h? That's going to give us 3 plus h. Then 2 plus h plus itself, that's going to give us 4 plus h again, which we already talked about as just h. And then what about 2 plus h plus 3 plus h? Well, that would give us 5 plus h if we take it literally. But again, 5 plus h doesn't exactly match one of these four things. So which of our four coset representations would that agree with? Okay, well, here's our 5, and that means that 1 plus h and 5 plus h have to be the same cosets. Okay, so we will rewrite that as 1 plus h. Okay, and you kind of get the idea. If you fill in the rest of these, here's what we're going to get. Okay, I'll let you check me on these last few entries. And we have completed our Cayley table. So there's how the operation of coset addition works in this factor group.